So this question is from organic chemistry, and from organic chemistry, you will find a complete question. The table shows the name or the structure of organic compounds from P to U. So different, either names are given or their structures are given. The first question, give the letter of organic compound from P to U that are unsaturated hydrocarbon. What is the meaning of unsaturated hydrocarbon? The term unsaturated means that they contain carbon and carbon double bond. So between the two carbon atoms, if there is a double bond, we call them as unsaturated hydrocarbons. So when we check P, P is not an unsaturated hydrocarbon. It is saturated because there is a carbon-carbon single bond. Propanoic acid will be CH3, CH2C double bonded with O and OH. There is a double bond, but that double bond is between oxygen and carbon, not between the two carbon atoms. That's why it is not an unsaturated. When we check R, but1-ene, ene means that there will be a double bond. So R is unsaturated. Then propane 1-ol means like 3 carbon atoms and OH is attached with the first carbon, but there is no double bond. Methyl butanoate, so it is an ester which contains C double bonded with O. One side, 1 carbon is attached and the other side 4 carbons are there. So that also does not contain any carbon-carbon double. There is a carbon and oxygen double bond, but not carbon-carbon double bond. And when we check the last one, you can clearly see there is a double bond in the structure. So that's why R and U will be the unsaturated hydrocarbon. So the term unsaturated means that they contain carbon-carbon double bond. Then describe a test for unsaturated hydrocarbon. What is the test for unsaturated hydrocarbon? We always use aqueous bromine or a bromine water. So we use aqueous bromine. Aqueous bromine, originally it is orange in color, but when it reacted with alkene, it decolorized. So observation, the orange color will disappear or the color changes from orange to colorless. In part C, but1-ene is unbranched molecule. Name the unbranched isomer of but1-ene. So we have to name an isomer. Like you can see but1-ene. What is the meaning of but1-ene? But1-ene means 4 carbon atoms are there. And between the first 2 carbon atoms, there is a double bond. That is but1-ene. I'm not drawing hydrogen here. What will be the isomer if we want to draw an isomer of alkene, the unbranched? So what we simply do, we change the position of a double bond. The double bond with the first, then we'll make a double bond with the second. So when we make a double bond with the second and third carbon, this will become but2-ene. So this will be but2-ene. So in the question, they're saying you have to name an isomer. You have to name unbranched isomer of but1-ene. So unbranched isomer of but1-ene will be but2-ene. And draw the structure of a. Now the next part, you have to draw the structure of branched isomer. Show all the atoms and all the bonds. So we have to show branch. How to represent a branch? But means 4 carbon atoms, but we have to show branch. So first 3 should be in line, and the branch is always either with the second, not with the first one. So this will be either you can make up or down. It does not make difference. And now complete the structure, because but1-ene, you have to draw an isomer. So if this will have double bond, this will have single, and this will also have single. Then we place the hydrogen. This carbon is having two bonds, so remaining 2 hydrogen. This carbon already formed 4, so there's no hydrogen. The branch one will have 3, and this one also have 3. So this is the isomer. As they mentioned, draw the structure of branched isomer. So branched isomer means we have to show branch either up or down with the second carbon atom. So if I want to draw an isomer of but1-ene, what are the possible way? Now, one is I can change the position of double bond. Like but1-ene means the double bond with the first carbon. But I can simply change the position of a double bond. I can make a double bond between the second and third carbon. Like here, I can put a double bond. Rest all will have single bond, and this will have 3 hydrogen. This will have 1 hydrogen. This will have 1 hydrogen, and this will have 3 hydrogen. So this is one way. But this is not the branch. This is just we take the same straight chain, but we change the position of double bond. If we want to make a branch, what we do? We draw 3 carbon in a straight line, and we can put a branch either up or down. So I can put a branch up or down. That does not make difference. And then we make a double bond here, single and single. Then remaining will be hydrogen. This will have 2 hydrogen. This will have 3 hydrogen. This will also have 3 hydrogen. So this is a branch isomer, like we make a branch. Or you can also draw a cyclic alkane. Cyclic alkane means like without any end, all are in a complete closed structure. And this each will have, this will have 2 hydrogen, 2 hydrogens, 2 hydrogen, and 2 hydrogen. So these are the 3 structures which I drew. Why we call their isomer of the top one? Because what is the molecular formula of this? It was C4H8. When I write a molecular formula of this one, it is also C4H8. What is the molecular formula of this one? C4H8. Molecular formula C4H8. So when compounds have the same molecular formulas, but they have different structure, we call them as isomers. So in the question, they asked, draw an isomer of alkene, which is a branched. So we have to draw which one? We have to draw this one, the second one. As you can see in this part, they're asking draw the structure of branched isomer of butanene. So we have to draw the branched one. So that's how we drew the branch one, because but means 4 carbon. So there will be 4 carbon, but we want to make branch. So 3 of them we draw in a straight line and 1 as a branch up or down. But they said show all the atoms and all the bonds. Like example, if I write like this, if I write CH2, this will be wrong. Why it is wrong? Because they mentioned show all the atoms and all the bonds. So I have to show the bond between carbon and hydrogen as well. The next question, next part, dodecane contain 12, it is an alkane and it contains 12 carbon atoms. We have to deduce the formula of dodecane. How to deduce the formula? Because it is an alkane, the general formula to find any alkane is CnH2n plus 2. Means the number of the hydrogen are always twice plus 2 compared to carbon atom. So dodecane means 12 carbon atoms. So value of n is 12. So when I substitute here, if C12, H will be 12 multiplied by 2 is 24, and 24 plus 2 will make 26. So the formula of dodecane will be C12H26. And how I work out? By using a general formula for alkanes, because they mention it is an alkane, so it should also follow the general formula. Then give the letter of all organic compound from P to U that can be formed when dodecane is cracked. So when we crack dodecane, when we break like 12 carbon and 26 hydrogen, what could be the products, or what products could be formed? We have to check according to the question. Remember, whenever alkanes are cracked, we discussed this, whenever alkanes are there, long chain alkanes are cracked. So whenever long chain alkanes are cracked, what will be the product? It can produce alkene, it can produce alkane. So these are the possible products for cracking. Like cracking of a long chain compound gives alkene and alkane. So basically, they are asking give the letter for all organic compounds from P to U that can be formed when dodecane is cracked. So from the list, we just have to identify alkane and alkene. So from P to U, we just have to identify which one is alkane, which one is alkene. So when you check this one, P is an alkane, so this can also form Propanoic acid, no, because it's not a hydrocarbon. Butanene, yes, because it's an alkene, can be formed. Propane-1-ol is alcohol, cannot be formed by cracking. Methyl butanoate is an ester, cannot be formed by cracking. And this is alkene as well, U is alkene. So what are the compounds can be formed by cracking of a dodecane? Because cracking produce alkane and alkene, so P, R, and U. So the compounds which will be formed will be P, R, and U. The next question, name the reagent and suggest the condition needs to convert organic compound U to S.
Recording in progress.
So we have named the reagent and suggest the condition need to convert organic compound U into S. So how U can be converted into S? What is U? U is alkene. So compound U is alkene and S is alcohol. So I have alkene and I want to convert into alcohol. So how alkenes can be converted into alcohol? Like if we have alkene and the final product we want alcohol. So how alkene can be converted into alcohol is simply by reacting with steam, or you can say water. So if we react with steam or we react with water, and what are the reaction condition, at what condition this reaction proceed or occur? So we use the temperature should be higher, like around 300 degrees centigrade, and we use catalyst. The phosphoric acid is used as a catalyst. So conversion of alkene into alcohol, the reagent, the substance which we need for the reaction to occur. Reagent means the chemical which we need. So which substance we need? We need water, or we can say steam. And the condition, it should be high temperature, around 300 degrees centigrade. And catalyst is used for this reaction as phosphoric acid. So you have to learn these reaction conditions when alkene convert into alcohol. The next part, organic compound S can be converted into organic compound U. Name the type of chemical reaction and name the acidified reagent. So the condition for converting, because they're saying S can be converted into Q, like this compound S, which is alcohol propanol, which is CH3, CH2, CH2OH, alcohol, can be converted into carboxylic acid, CH3, CH2, C double bonded with O and OH. So how alcohol can be converted into carboxylic acid? This reaction is known as, it can be reacting with oxygen in the presence of oxidizing agent. And this reaction is called oxidation, because the term oxidation means addition of oxygen or removal of hydrogen. You can see there are two hydrogen here, but these hydrogen are removed and carbon bond with oxygen. So that's why we call oxidation, as oxygen is added. So to convert alcohol into carboxylic acid, the reaction is simply known as oxidation reaction. And the reagent which we use potassium manganate 7. Again, this the name of the reagent you have to memorize. So name the type of reaction. What we call that as oxidation, because oxygen is added here. So alcohol convert into carboxylic acid by oxidation. And name the acidified reagent which we add, like we have to mention the oxidizing agent. So the oxidizing agent, it is always fixed. We use potassium manganate. So acidified potassium manganate 7 is used as an oxidizing agent. So you have to memorize the oxidizing agent for converting alcohol into carboxylic acid. So it remains fixed. The conditions, same like converting alkene into alcohol, the condition always remain fixed around 300 degrees centigrade, high temperature, high pressure, catalyst, phosphoric acid. So same thing for converting any alcohol into carboxylic acid, the conditions remain same. It will always be potassium manganate 7. Then organic compound T is made by reacting two other compounds. Name the homologous series that compound T belongs to. What is compound T? The compound T is methyl butanoate. So what is the class of this compound? This is called ester, because O8 is there. From O8 you can identify it as an ester. And which two reagents react to form this ester? Remember, the first name of an ester is always from the alcohol, and the second name is from carboxylic acid. So example, if we have methyl butanoate, so the first reagent is always coming from alcohol. So basically the reagent which react here, that will be methanol. And the second name of ester is giving the acid which react, because acid react with alcohol gives ester. So it will be butanoic acid. So when methanol plus butanoic acid react, they will form this ester, which is methyl butanoate. So the question is, which class or what is the family of this organic compound, or which functional group is present here? So name a homologous series, or name a family from which this compound T belongs to. So it belongs to ester. And name two compounds which react to form T. As I just mentioned now, how T is formed. How the compound T is formed. The compound T is formed by reaction of. So the compound T, which is methyl butanoate, it is formed by reaction between methanol and butanoic acid. So we have to name the compound and we have to draw the structure, show all the bonds and all the atoms. So methanol, how to draw the structure of methanol? Meth means one carbon, so I will draw one carbon. And all means alcohol means OH group is there. And this will have, because carbon maximum can form 4 bonds, so this will have remaining 3. Then the second reagent, what will the second reagent? We already worked out that it was butanoic acid. So we have to draw the structure of butanoic acid. But means 4 carbon. So 1, 2, 3, 4. And oic acid means the functional group is C double bonded with O and OH. So it is C double bonded with O and OH. Then this will have, all will have a single bond, and then we have to show all the bonds and all the atoms. So this will have 3 hydrogens. This will have 2 hydrogen. This will have 2 hydrogen. So this is a complete structure of butanoic acid with all the bonds and all the atoms. Then the last part, we have to deduce a molecular formula of T. How to deduce a molecular formula of compound T? Molecular formula represent the actual number of atoms. So methyl butanoate, what is the structure of methyl butanoate? The structure of methyl butanoate is C double bonded with O and O. Meth means 1 carbon here and but means total 4 carbons. This will have So this will have 3 hydrogens. This will have 2 hydrogen. This will have 2 hydrogen, and this will have 3 hydrogen. So we have to deduce this is a compound T methyl butanoate. We have to deduce molecular formula. The molecular formula represents the actual number of atoms. So we'll count how many carbon atoms are there. So 1, 2, 3, 4, and 5 carbon atoms. So we'll say C5. And how many hydrogen are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. C5H10. And how many oxygen are there? 2. So C5H10O2. So that is a molecular formula of this compound T. Molecular formula actually represent the actual number of atoms present in the structure. And see the weightage of the discussion, it's total 20 marks. So it's about 25% of your paper based on this organic chemistry. And there's also another question in this paper. Question 6 is also from organic chemistry. The polymers are large molecule built up by a small molecules. So when large molecules are formed by the small molecule, we call that as a polymer. State the name given to small molecules. So what we call these small molecules, the name given to small molecule, they are known as monomers. Small molecules are monomers and the large molecules are polymers. Then the formula of the polymer is shown here. Draw the structure of small molecule. How to work out the structure of small molecule? We'll just take the 2 carbon atoms which are there given in the structure. So we'll draw them as it is. And monomer in addition polymer, whenever addition polymer is formed, the monomers contain a carbon-carbon double bond. So only thing what we'll do between the 2 carbon atoms will make a double bond. So monomer will have a double bond, polymer does not have a double bond, and long chain compound is there, a polymer. But this is a monomer. So whenever they ask to draw a monomer from the polymer, what you will do? You will draw the same structure, like take the first 2 carbon atoms and draw as it is the same structure. And then only what you will do, put a double bond between the 2 carbon atoms. So this one is a polymer. This one is a monomer. Then state type of polymerization used to make this polymer. What kind of polymerization is this? Whenever we have a monomer, alkene is there. So the type of polymerization is known as addition polymerization. If it was like alcohol and carboxylic acid or amine and carboxylic acid, then it will be condensation. Condensation polymerization, water molecule is released. But addition polymerization, the small molecules, the monomer join to form a long chain compound, and monomers always include a alkene. So 3 amino acids combine to form a natural polymer. Name the type of natural polymer formed when amino acids combine. So what we call, whenever small molecules, the monomers such as amino acids, they combine, this will produce a natural polymer by nature. And what we call this polymer is known as protein. If amino acids combine, it will be protein. In second part, complete the diagram to show the part of a structure of natural polymer that could be formed when these 3 amino acids combine. Show all the bonds in the linkage. So when these molecules combine with each other, what will happen? For amines will always lose their H, like the amine group, the NH2 group will lose its one of the H. And carboxylic acid, when it is combining with The carboxylic acid, it contains C double bonded with O and OH. So for polymerization to occur, the amines will lose its H and carboxylic will lose its OH. So what we have to do, like NH2 is there, so one of the H should be removed, only one, not both of them. So this will be N, and we have to show all the bonds. So that's why first it was NH2, but one of the hydrogen is removed. Now what will happen? This will lose its OH, and amine will lose one of the H, not both. So this will be CO means C double bonded with O, and NH means N with H. And now, because nitrogen have one bond and carbon also one bond, so they will link with each other, which we called amide or a peptide linkage. Same thing happened with the other side. Carboxylic acid will lose its OH and amine will lose one of its H. So it will be C double bonded with O, and amine will have N and H because it lost one, and then the nitrogen and carbon will link with each other, which we call amide or a peptide linkage. I can make hydrogen up or I can make hydrogen down. That does not make difference to the final answer. And same thing, this will lose its OH. So this will be C double bonded with O and continue. So this is how condensation polymer is formed when amino acids or amino acids react with each other. So amines will always lose their H during polymerization, and carboxylic acids will lose their OH. So we remove H from one and we remove OH from the other, and we link them together. Then name the type of chemical reaction that take place when this natural polymers is converted back to amino acids. So the forward reaction when amino acids form this protein, we call polymerization. But if we convert the protein into amino acid, what we call that as hydrolysis. Hydrolysis means breakdown of the molecule by the help of water. So when natural polymers, condensation polymers decompose or break down, the reverse reaction is known as hydrolysis.